Due to the advent of fitness trackers, smart wearables are about to steal the show, and it makes sense. It is projected that 17 million smart wearables will be sold in 2018, while fitness trackers continue their decline. You can do more with smart wearables and apply them to watches, glasses, activity trackers, and healthcare devices. It does more than the Fitbits you already have. It has a step counter, a calories expended counter, a sleep monitor, and it can connect to iPhones. But those extra features come with a hefty price, and in this case, it's battery life. We have all experienced the hassle and letdown when our devices lose battery, and that's why Matrix Technologies has come up with a solution to that notorious problem. Because of Matrix Technologies, you will be able to power its smartwatch using your own body heat. The principle behind this watch is the Seebeck's effect, which is the production of a voltage due to a temperature gradient. The heat causes holes and electrons of a semiconductor to flow, and when connected, this produces a decent amount of current. The reverse also works. A voltage can be used to produce a temperature difference. To optimize voltage production, the material must have the following: a high Seebeck's coefficient, which is the ratio of the voltage produced and the temperature difference, a high electrical conductivity to still function, and especially a low thermal conductivity to maintain the temperature difference. A material with these properties is hard to find and fabricate. In 2008, an article was published in Nature Journal entitled Silicon Nanowires as Efficient Thermoelectric Materials by Akram Bukai et al. They found a way to fabricate a material that would be great for optimizing thermoelectric systems. The clever thing the inventors did is that instead of looking for a material with inherently high Seebeck's coefficient, they modified the semiconductor structure instead. They used silicon nanowires and arranged them in an array. The figure on the left shows their setup. They placed the silicon nanowires in between the temperature gradient and tested its performance. They understood that the key was to prevent heat dissipation and maintain temperature difference. This was done using silicon nanotubes because these hinder the propagation of heat but still allow electrons and holes to flow. In a quantum scale, heat can be understood as lattice vibrations or phonons. These phonons were prevented from propagating because their mean free path is shorter than the size of the nanowire. Phonon movement in bulk silicon is also three-dimensional, whereas in silicon nanotubes, the movement is only one dimension. This silicon nanowire technology yielded a Seebeck's coefficient of greater than 1, which is significantly greater than most. The inventors submitted their patent less than a year after working on silicon nanowires. From the data in their study, they knew the specs of their invention and foresaw its performance. They filed a patent for a device that can control thermal conductivity and thermoelectric power of semiconductor nanowires. 7 years later, they are looking to improve on their design and systems. The photo on the bottom left shows the team who developed the Matrix Power Watch. Like I said earlier, this technology could be expanded to other wearables, and in doing so, you never have to worry about losing battery. Just imagine never having to plug in your phone or your high-tech glasses to a socket. As long as you are holding your phone or wearing your glasses, they will never lose battery. It is also possible to improve the Matrix Power Watch by adding a cooling system to one side using the microfibers of the McDavid towel. These fibers can maintain temperature difference, and this brilliant new idea can be placed within the watch to optimize its performance. Lastly, recall that it works the other way. The reverse of the Seebeck's effect is called the Peltier effect. If we could generate a significant amount of power with little temperature difference, maybe it is possible to create a large temperature difference with just little power. Your air conditioner or refrigerator will use less power while maintaining the low temperature. All this could be possible with Matrix technologies. Thank you very much for listening, and here are my references.